Okay. All right. So, questions on that mixture and compound business? Now, you good? Different percentages means there has to be a different amount of lead and sulfur in each rock. That's what that first part says. Certain percentage of sulfur and lead by mass. So, here's how I would do this. So I would say, all right, A for X is going to have one sulfur one lead and one sulfur. Maybe I'll just do 2 and 2. Okay. So what's the percentage of lead here? 50. What about sulfur? 50. So now this one needs to have a different percentage, right? Because it says one rock contained a certain percentage and the other rock's a different percentage. So now maybe I'll do 1 lead and maybe I'll do 3 sulfur. So now that's 25% lead and 75% sulfur. That's a mixture because they're not touching. That's a mixture because they're not touching. This is 50-50. This is 25-75. Literally all of us could draw something different and get this right. So I don't know what you have. Obviously I know I didn't walk around and look closely, but that's what you needed to do. So you could have 2 sulfur and 5 lead. You could really, there's like an almost unlimited way to do this correctly. It's just this percentage needs to be different. It doesn't even have to be 50-50. I could do this. I could do another sulfur here. So I could do 3 here and 2 here. That's a different percentage than this because that's 3 to 1. Okay, so just the ratio has to be different. Same thing for Y, except if I was to do this one's harder, I feel like. If this is the compound I drew in rock A, and I could draw another one. Okay, so that's a compound there, lead sulfide, and it's 50-50, meaning you have 1 Pb and 1 S, right? 1 Pb, 1 S. This one, the easiest way, at least my mind works, is I would do something that looks like that. I would make a different compound, so that would be PbS2. So I would have 2 S's and 1 Pb, so that's a different percentage, right? So if this is the compound, then it's like 33% lead and then 66% sulfur, right? So it's a 1-to-2 ratio here, and this is a 1-to-1. So that's, I think, why is harder to understand because you need them to touch. And a lot of kids want to just do this, and what a lot of kids will do for rock A is they'll do this. So imagine in here I did this. So instead of 2, let's say I drew 1, and then over here, this is what they do. They do this, and then they draw another one. And then they try and tell me, wait a second, this is just 1, and that's 2, so there's more of it. It doesn't work that way with compounds. If I have 1 grain of salt, or an entire pound of salt, it's still the same ratio, Na to Cl. 1 Na, 1 Cl. So it's still 50-50. Doesn't matter if you drew 2 or 1, it's the same ratio between Pb and S. So that's why the only way to really get this completely right is to have a different compound. Then the ratio or the percentages are different. That's not an easy question. Did anyone get it right? Good job. Honestly, I think the first time I did this, a long time ago, I found it, I did it myself, I got it wrong. I did something similar to that. Like I did more of the same, and then I was like, oh yeah, that's not going to work. So it's not an easy question. Okay, so again, lab Friday, we'll be taking a particle diagram quiz. Sometimes I give lab quizzes in labs just to save a little time in class. All right, we got 10 minutes-ish. So take out your notes. Let's move on. Lights, please, right here. All right, something new here. And Nicole and Natalia, don't forget, I got to talk to you. Okay. Hold on, let me just double check. I'm not forgetting to tell you guys. All right, we did that, we did that, we did that. All right, we're in good shape. On the board, what did I write? When's your first test? Next Wednesday. I have a review sheet. Okay, I'll give that to you tomorrow. 5-week test. So 5 weeks was over last Friday. So it's only been a couple days. I'll give you a review sheet. It's on everything from the beginning of the year. I'm not going to ask you names and symbols. That stuff is over. Okay, you need to know it, but that's not what I'm going to ask. I'm not going to ask group names. That stuff's too easy. It's going to be periodic table questions, particle diagram questions, physical chemical changes, mixtures, elements, compounds, so that kind of stuff. All right, here we go. So before I get into this here, let's write this down here. Chemical reactions, conservation of mass and energy. All right, so I just do an overview on chemical reactions here. In other words, like it's just the general formula, like what the heck is a chemical reaction. You have reactants on the left, they yield, so the arrow means yield, products on the right, and I think you already know this, but just write it down anyway. So for example, if we take hydrogen gas and react with oxygen and we make water, that is an example of a chemical reaction. This would be called synthesis. Take H2 gas, oxygen gas, and you make H2O gas or liquid. So you take two elements, combine them to make a product, a compound, and that's just one example of a chemical reaction. So you just need to understand where reactants are, where products are, what the arrow means. Now we can talk about conservation of mass and energy. Whoa, that was almost bad. All right, conservation of mass, conservation of energy. Raise your hand if you've heard of those things before. Everyone should have, you're just not raising your hand. Okay, Z, what's conservation of energy mean?
It means that it can't be destroyed or created.
Can't be, what can't be? So he said conservation of energy means energy cannot be created or destroyed. Raise your hand if you agree. Raise your hand if you're not sure. Okay, what's conservation of mass? Same thing except with mass. That mass can't be created or destroyed. So if mass isn't created and energy isn't created, and it can't be destroyed, where does it come from? Food. Where's food come from?
Happy places.
Happy places. That's weird. What? Where's mass and energy come from? Do you have mass? Are you guys made of mass?
Doesn't mass come from like gravity or whatever?
Mass comes from gravity. Huh. Mass is affected by gravity. He's right. I like his definition. Mass and energy cannot be created or destroyed. What can it do? What can happen to mass and energy? Change forms. Good. Can be transferred. Let's write this down. Conservation of mass and energy. What does it mean? It means mass and energy cannot be created or destroyed. Mass and energy cannot be created or destroyed. Oops. And I'll get back to that equation in a second. Mass and energy cannot be created or destroyed. Only, underline that, transferred. Literally, I do the same thing every year, like a broken record. I don't know how to spell transfer.
Isn't it 2 R's? T-R-A-N-S-F-E-R.
I think it's 1 R.
It's 1 R.
I always feel like there's 2 R's or 2 F's or something. I don't know why I do that. I'm bad at spelling. Only transfer. And you said change form, right? I like that. Let's put that too. Change form. Okay. All right. Now, tomorrow I'll show you a demonstration of conservation of mass. I didn't have time to set it up today. But right now, I'm going to show you conservation of energy. A little demo. It's pretty cool. Look at that equation that we just wrote. H2 plus O2 yields H2O. Anything wrong with that, Solon? Or anyone else. Is there anything wrong with that equation? I'll give you a hint, there is.
Wait. That was.
Alright, scratch that demonstration. The thing I use looks to be broken. So I'll figure that out. That's really irritating me right now. Okay. So I'll have to figure that out for tomorrow. Solomon, what do you think?
You started with oxygen.
Say it again?
We only ended with one oxygen.
Right, so we have two hydrogens. Let's use the magnets because they're more fun. We have two hydrogens here, and we have two oxygens. All right, but over here, we only have one oxygen. Good. All right, so Kara, are you with me?
Yeah.
Okay. What law is this violating? Yeah. There's two laws. Conservation of mass, conservation of energy. Which one is this picture apparently violating? Yeah, mass. So hydrogen has a mass of 1. So this would have a mass of 2. 2 grams. What would the mass of 2 oxygens be? What? That's for 1O. We have 2. 32 grams. What's 2 plus 32? 34. Okay, what's the mass of water? 18. 16 plus 1 plus 1. Conservation of mass for a chemical reaction means the mass of your reactants must equal mass of products. That's what this means. You can't create it, you can't destroy it. So if you start with 34 grams, you better end up with 34 grams or something's wrong. Anyone see where I'm headed with this? You learned this in biology, I'm pretty sure. I have to put these big numbers in front. What do I do? What do I have to do to this equation? Called balancing equation. Have you done that before?
Yeah.
Yes. Okay, so you have to balance equations. Balancing equation is what proves these laws correct. And I'm really irritated that my thing is broken because I wanted to show you the conservation of energy, so now I gotta figure something out.
There's always YouTube.
No. This is something you have to experience. You have to experience the science on this one. You feel it. You actually touch it and feel it, actually. Anyways, I'll figure it out. So, what's the deal? This is conservation of mass that I'm trying to show you. We've got to balance this. You said you know what balancing is. What do? Who knows how to balance equations? I feel like you've learned this. The reason because your brother was talking about this the other day, and he seemed like he knew more.
I know how to.
Okay. I'll give you guys a jump start here. If I put a 2 here, what that really means is I have 2 hydrogens. So I have 2 H2s. That's what that means. Okay. That's your jump start.
You have to have one equal.
So let me rephrase this. Mass cannot be created or destroyed. What that really means is the number of atoms on the left side must equal the number of atoms on the right. So right now, how many yellow do we have? 4. How many yellow here? 2. That's not balanced. Think of scales. They have to be equal. How many green? 2. How many green? Doesn't work. We're breaking the law of conservation of mass. You want to add another water? So he wants 2 of these.
You have to do the other 2 or the other oxygen.
So if we have 2 waters, it's going to look like that, 2 Mickey Mouse. Now, are we balanced? Yes. We have 4 here, 2 here. We have 4 of those, and then we have, this is kind of 2 of those. So you have 2 green, 4 yellow, there's no point in really writing it, just count it. So, we'll pick up with that tomorrow, and hopefully I'll figure out another way to show the demo.